Oh god, I'm late. Hello all. Hello world. This is day 216 of studying compilers every day until I land a compiler role. Last time we decided we low-key don't want to do more array stuff or more front-end stuff, so we decided to push off arrays into the future. And we decided to start doing more middle-end passes. So we started a simplify slash reassociate sort of optimization, I guess, as a part of inst combine. This time, it's going to be a bit of a shorter stream because I've got plans at end of hour, or maybe a little bit sooner, depending on how long people take. So we're just going to debug that and maybe do a little bit of rewriting to make it like less awful. And yeah, it's going to be a good time, I hope. So yeah, let's get straight into it. The first thing I want to do is this entire thing is kind of messy. So I think I want to modify my inst combine pass a little bit, just with like some more private fields, just so it's a little bit more maintainable. So we're gonna move the, I think we just move the visitor into here. I think that'll be a little bit cleaner. Yeah, and then this also means we can like, I think we can separate it out. Oh, actually we do have to do this like literal thing, huh? Yeah, that's a little annoying. Yeah, that's not ideal. Okay, well that explains why I didn't separate it out earlier. Okay, well, we'll figure that out in a second. I want to make a helper function to like delete something, I guess. Because I think that might be a little bit ugly. Where is this to-drop thing made? It's just at the top here. Okay. I guess this is probably fine. We can probably leave that as is, but I want more maintenance tools, at least, to make this a little bit less ugly. Also, these like visitors are really annoying. I think if we had a wrapper, that might make it easier to use. But yeah, I don't know. This is all just like very ugly code, just by nature. So we kind of have to deal with some of the consequences of that as we work. Yeah. Maybe we could make like a drop helper. Yeah, we should probably do that. Let's do like, I don't know, this is really ugly. We can just do erase and then give like, I don't know. I don't know. We'll just do this for now. It'll be ugly and it'll be fine. I really wish we could like pull these functions out though in some way, but it seems like we kind of just have to leave it as is. Yeah, we'll just do this. We'll just do this and call it a day. But I think we're dropping correctly at least. So if we go back up to here, we replace uses, we do all that. Compared to this is about the same process, right? So I'm not sure why it's segfaulting. Yeah. So let's just rebuild it. Let's see what happens. Call chain. So we'll be quick with this. Segfaulting and get value. Line 169. Is that here? Right literal doesn't exist. Uh, oh, I know why. I forgot to change it. This should just be constant. Whoops. Yes, we can do that. Oh, that's so stupid. Yeah, let's just change all of these. Yeah, I think that'll be easier. Yeah, we can do that. And then we're good to go. Hopefully we're good to go at least. Okay, it fails tests, which is good, I think. Oh wait, no, it still crashes on call chain. Sorry, I just opened a group chat to some really heinous shit. Anyways. Okay, let's look at this again. Where are we going wrong? Holy. Uh-oh. I think we're in trouble. I think we're a little bit in trouble right now. I don't know where things are going super wrong, but things are going super wrong somewhere. Yeah, something has gone wrong. Let's start at the top here. Bracket operator. What the fuck? Add use. What the f- What are we running? Okay, we're on simplify CFG. This does not make sense. Okay, what is breaking here? Like, genuinely, what is breaking here? Maybe our replace use visitor is constructed wrong? Oh, this should be good, right? Because we do something like that above as well. What the shit? Yeah, so we replace all uses of the binary op with the variable, which that should be good. So like, what happening? None of this shit makes sense. Also double ping, unlucky. What's up, Sack? Isn't the compiler work going to be redundant because AI? Not necessarily. First of all, like, the big difference between compiler output and AI output is one is very deterministic and the other isn't. Like, if you give like a C program to an LLM and you tell it like lower this to assembly, sometimes, I guess with simple programs it should be like fine, but at least with more complex programs you might not necessarily get like the same assembly output. Second, if you were to do that with a large program, it gets pretty expensive pretty quickly. So that's probably a little bit suboptimal. So there is still gonna be like, compilers are still gonna exist, and like they are necessarily gonna need people to work on them. And third, I think AI creates more opportunities for compiler work because, I guess if you look up like ML compilers, right? There are compilers that convert like matrix multiplication and like tensor operations. It takes those and it optimizes those and it vomits out more, I guess, well, optimized code. So if you look at like, there's like various different graph compilers or ML compilers, which are two distinct things. There's like this nice intro article that I read way back in the day, and I think this is probably like a good introduction to what that sort of field is. But bottom line, compilers for general purpose languages will still exist for the most part, and there are new opportunities for compiler work that are created by AI. But again, I'm also like, I might be a student, and none of us know what's gonna happen in like 10 years. So like, we'll see what happens. And like even if like compilers disappear, this is like still a big pile of fun. So who am I to complain? What year are you? I am 4th year right now, and I'm finishing my master's fall quarter, or this upcoming fall quarter. Yeah, like it's all a good time. I enjoy the depth of the field. I enjoy like the PL side of it to some degree, and I enjoy the systems-y side of it to some degree. It kind of fits in just like the general, I guess like generally speaking, the areas of computer science I like, and just like the properties / like tasks within computer science that I enjoy. Okay, so why is this quitting on me? Let's just run it with mem2reg and then inst combine. You stream late? Yeah, fair enough. I've been trying to like move it earlier, but I've been very inconsistent with it, so that's kind of just life. Okay, interesting. What the hell? Get type? What's in return? Are we replacing uses in return properly? Oh. Wait, that might be something we need to worry about. Right? Oh, wait a second. We have uses. Is it just, am I not constructing uses properly? What the hell? That's an insane bug to run into. Ah, wait. Yeah, that should be fine. This doesn't make sense. Now, what is breaking about this? Is this condition correct? That should be correct. Or this condition. Yeah, none of this makes sense. This shouldn't be like quitting like this, at least. I think we modified the test as well, right? Okay, so we have this. So if we uncomment that, or recomment that, does this work? Okay, that still fails. So something like really went wrong. Or maybe if we just only do this for now. Or what does it look like with just mem to reg, first of all? I think that might be a good start. Let's do that. So now if we look at the output, oh, I'm looking at the wrong test, duh. Let's give it inst combine. Obviously we should give it inst combine, I think. So let's see if this generates correctly to begin with. So let's get rid of call chain. Let's look at this. Okay. So we have add, and sub. Okay. So these do generate exactly what we want. Let's see what happens if we run it with inst combine now. Okay, so that just works. Okay, well, I guess it kills all the dead code because we wrote the test poorly. Let's just return res like that. Let's try that again. Okay, that's not supposed to happen, I think. Right? Oh wait, no, these are... No, this is fine. That is necessarily supposed to happen. So it looks like that's correct. So now if we just lower all the way, that should also work. Or that should quit somewhere. Yeah. So that looks like it's correct, which is really strange. I'm not sure why call chain is breaking then. Which tech stack do you think is more worth investing your time into creating projects? I mean, a lot of it obviously depends on your goals. Low-key, you've kind of listed two languages that are kind of the same. I think, generally speaking, there's a lot more legacy Java code than C# code, though. Because Java kind of just got the first adopter advantage for the most part. The bottom line of that is, like, there's a lot of, like, old APIs, or, like a bunch of, like, just old code everywhere, actually, to be honest. Both in, like, large companies, small companies, games, etc. All written in Java. I guess C# is more prevalent in, like, games, but, like, pretty much everywhere else, there's more Java. So I think that's probably... If I were to pick one, I would pick Java, but realistically, they're kind of about the same. So I don't really think it matters too much. Yeah. It's still your choice. Okay, let's try this now. I guess we could just throw in all of the other operations real quick. Oh, we could also do like multiply by 0 now that I think about it. Yeah, I guess, yeah, we could definitely throw that in actually. That might be interesting. Yeah, let's try that. Let's be a little immature and have some fun here. Or actually no, we can just keep using res here. What's up, Niraj? I guess a lot of this becomes dead code, huh? Let's just do that. So we have that. We want that. And then what else did we want here? Yeah, we're debugging. Yeah, so our school offers like 3 master's options. There's like just coursework only, there's like a project option, and there's a thesis option. I'm gonna be doing like I'm gonna be doing a thesis. Right now, the work is on comparing, I guess, code quality between Rust and C compilers, and just looking at what differences the optimizer language has and how we can use that different information to make better optimizations for Rust. Because the Rust language is very different, but they still share the same like optimizer language. That throws away a lot of like interesting info that we can use for more optimizations. So it throws away a lot of it, but it also preserves some properties of the program that we can either use to write better, I guess, make more aggressive optimizations or make certain algorithms faster, because these programs have like very specific properties that are distinct. What's the salary you'd like to have? I don't know. Honestly, like, I think it'll be comparable to like general SWE anyway. So like, I'm not really thinking too much about like total comp. It'd be cool to get paid off like a decent amount, obviously, but I don't think it's like that primary concern as long as I can like live pretty comfortably. Just from like a practical perspective. If not, then like, I don't know, I can supplement it with the additional like 50 cents of ad revenue a day I get. Like, I don't know. Okay, let's see. What else do I need? We want and here. So we want to and it with -1. Yeah, I'll do that. We want to OR it with what? OR it with 0. This is getting a little bit ridiculous. We'll just generate all of it. So we have that, we have multiply with and, that's good. We need the shift, and we have division, so we just need shift, I think. So we don't want that. Yeah, we'll just do that for now and call it a day. Why don't you make videos on the stuff you're learning in a fun, informative way? That's something that's on my planning list. I want to make better educational. I want to make like better educational resources on things that are like honestly not covered enough in compiler classes. Like, if you look at the structure of a compiler class, usually it's like half of the class is just parsing for some reason, which doesn't make sense. And then like you really quickly speed through like some optimizations, you speed through like code generation. And then like you learn what a parser generator is, and then like the first half of the class is like completely useless. I want to make more resources that fill that sort of gap. So like one of the videos I've planned is like just like basic SSA form and like why it's cool, why it's useful. Static single assignment. If you look up SSA form, you'll get like tax documents, which is not very useful. But yeah, static single assignment. It's used a lot in like compilers. LLVM uses it. GCC uses it. I think it's very hard to find a compiler that doesn't use it. It'd probably be like shorter form stuff, not necessarily like a course, but a course is something that I would think about, maybe for like something else. Let's run this again real quick. But yeah, there's stuff in the works. I haven't gotten a chance to like actually do any writing, but it would be really cool if I could get it to. It'd be really cool if that's something I could work on at least. Okay, this is neat. This is very neat. What's the point of people calling it SWE? Because it's like nice. I like saving syllables. I say as I'm very verbose with everything. Well, let's run it with inst combine now. Okay, so that didn't fold shit. Well, that's not helpful. Hmm. Yeah, that's not ideal. I'm not sure why that didn't fold anything. Huh. What's up, JMac? Yeah, this should be... Oh. Duh. That's why. Okay, so it does just fold everything. Which is what's supposed to happen. Gotta go to bed. Thanks for stopping by. Take care, man. Do the courses at your university teach you about architecture? Yes, but they're more leaning towards like computer engineering, or like electrical engineering. Much less so in like computer science proper. It's a little bit one of those like really awkward in between sort of domains. Okay, so this does fold. This does fold properly. So what if we just do O1 now? Does that crash? No, it doesn't. So, what doing? So why does call chain crash? No, it doesn't. Wait. Inst underscore combine. Okay, interesting. Where is it crashing at least? What's up, Carlos? Carlos. Like designing, oh, I see. I see. If you're talking about like more hands-on slash like practical courses, that depends on the school. I think more and more schools are offering these sorts of like practical hands-on-y sort of courses. I personally don't really find them useful because I feel like it's just stuff you can learn on your own, and like all you do is like you show up, you like twiddle your thumbs for like 2 hours, and like by the end of it you're like, I could have learned this in 10 minutes. So like, I don't know. It's all very personal preference. Some people enjoy like more self-teaching. Evidently, given the fact I'm doing this whole series, I prefer that sort of teaching style a little bit more, or I guess I'm more amenable to it at least. But I can understand why the class would be useful for someone that like is not as interested in like self-studying things. What's the purpose of your current compiler project? What does it compile? It compiles C to x86-64, or at least a very limited subset of C. I'm doing this mostly to learn more about middle-end optimizations, so like, well, the optimizations that a compiler makes on the code. But in the meantime, I've also kind of used this as a way to learn more about like, just generally speaking, how compilers function and why they're designed the way they are. That's kind of also the broad goal of this. I guess that's not really helpful, but yeah. Yeah. Oh, I see. This makes sense. This makes sense why this is failing. I forgot to put the braces here. This is very important, obviously. Okay, we gotta change the structure of this a little bit. Holy shit, that's really bad. Okay, so this one, it should be 1. And then this one should be -1. That should fix everything, I think. Yeah, okay, there we go. Much better. The reason why some people like being taught and not self-teaching probably stems from a clear roadmap and quick feedback. Yeah, that makes sense. I imagine if like a class like this was offered at my school, I would enjoy it, but unfortunately it isn't right now for various different administrative reasons. My school powered up those med school. I can't lie, I do not understand what you asked or commented. Okay, so this affects inst combine, this affects call chain, that makes sense. But it doesn't seg fault anymore, which is good. Do you feel like you got a good amount of info from Muchnick's book? It's like kind of awkward. I think it's been like useful, at least in terms of like figuring out what exists. In terms of like implementation details, I haven't been following it too closely, but I probably will somewhat soon. I've like only used it for like, what, 3 small sections right now. So maybe ask me in like a month or 2 and I'll have a better answer. But for now, it feels like the explanation is like generally fine. I think it suffers the same problem as like a bunch of older textbooks where like the language is like very proprietary and like the authors try to like coin their own terms for things, and it's like, and like you read through it with like modern knowledge and you're like, oh yeah, like what is this thing? Oh, he means like, what is X? Oh, he means Y when he says X, and it's like, okay, great. But yeah, I think it's like fine. I wouldn't read it as like a front to back thing as much as I would just use it as like a reference resource. Okay, let's generate regression tests real quick. Big C compilers are implemented in C++? Yeah, they're like, C++ is, I don't want to say it's better for like maintaining large projects, because like, Exhibit A, the Linux kernel, right? But like, I think at least for the types of programming that you would want in like a compiler, I think it makes more sense than C. Just for like large scale modularity / maintainability. Whereas C is like, if you look at like the way C is written in like an OS context, it's really just like user-friendly assembly, to be honest. Okay. So let's get add test, regression input, inst combine. Oh, we should delete that. Oh, yeah, we should add more tests real quick. I should add pre-commit tests. Okay. How do we want to do this? Let's let's add more to the test real quick. I just went all the way to the bottom. That's really stupid. Oh, okay. A fun way we could do this, actually, I think. Int should stay 0. We can use this to kind of like chain optimizations, which might be interesting. Or I guess this already gets simplified out, right? So it's like really awkward. Yeah, I don't really know how to test this very well, now that I think about it. This feels very duplicative, at least. Constant fold, I don't even know how we're gonna optimize this properly. I guess that all becomes constant, right? Yeah, like that all is constant, but this has like a dependency on I. Okay, so we could probably do it like that. So we can do that. We'll do like this, I think. We'll do 0 times I. Yeah, we could do like a pre-commit test on this, and that might be interesting. Okay, that name is annoying. I'll just do that. The interesting thing is 0 should get folded above, right? So I guess we could leave it like this. This is probably fine. This will just be like dead code and it'll get erased some other place. Yeah, like C++ feels like a standalone language more. Stood 6 times in one line. Yeah. I mean, like, you kind of get that in any sort of, like, object-oriented language. They do become very verbose, but that's life, you know? Okay, so this is inst combine, or simplify arithmetic pre-commit test. Okay, so we can get stash, and we can make, we want to regenerate. Yeah, we'll do that. We might actually want to rename the commit to like pre-commit test. Yeah, come on now, it can't be that slow. It might be that slow. But yeah. I think this will change exactly like one set of tests. Okay. So let's look at inst combine s.mir, that one. Yeah, so this does what we wanted it to. So we multiply by 0, we multiply by 0. Let's just do that instead. Let's regenerate them again, and then we will... I guess if we generate that, we should be good, right? Yeah, okay. That's what we wanted. So... Okay. So then... Yeah, we can do that. We can do that. Okay, cool. So now get stash pop, and then we can make, and then we can, okay, yeah, that's like failing the test that we know it's gonna fail. And now we regenerate the tests, and then we can look at the different output, and it's gonna be like really pretty, and it's gonna be awesome. Yeah, this sort of like magic where you write a bunch of algorithms and then like your code magically shrinks in size is like, this is like low-key what drew me into compilers. I think it's like top 3 reasons. If like the systemsy stuff was like reason 2, the PL stuff was like reason 3. Reason 1 is because this shit is magic. Like you have this giant chud program over here and it's like really ugly. And then you look at like test regression expected call chain s.mir, and then like, oh, that's call chain. This is the wrong test. That one is not magic. That one is evil. What the hell changed there anyway? That's a different issue. What was it again? Inst combine s.mir. Yeah, you look at this and you're like, it has shrunk down so much. We've cut out all of these garbage lines and it's just beautiful. We need to clean that up still, but git commit -m first sequence of identity arithmetic simplification. Okay, and then we want to do one more real quick, which is these other zero identity cases, which are fun. Yeah, we'll do that. So that also goes here. We can do this. We can paste that there, or we could just move this here instead. Or let's do it like that. Yeah, so there we go. That's good. And then this case, we're gonna make equals 0. We gotta change the constant, I believe. Oh, that's really annoying. Can we just do like ruv and redeclare this somehow? So we can do bin op, and then we can replace it with 0. Or we can just replace it with constant, right? How do we update this? I guess that is... We're just replacing it with the constant anyway, right? So like... Oh, wait, no. Yeah, we're doing it differently. Instead of var, it's constant. That's really annoying. I should just like make a helper function that does this. Honestly, this is getting a little ridiculous. We're gonna make it anyways, so like what's the point of pulling this out? Okay, real quick, we're gonna go to utils, replace uses. Let's make a little thing here. Replace uses. We'll just yank in that. Yeah, we'll do that. Probably end up reading Mushing's book front to back. I guess that's fair. I think it's like, I don't know, the book is just really dense. So I think like, I think that might be a little bit detrimental to your sanity. But like, I think it's probably like not that bad a thing to do at the end of the day. Okay, let's do this now. Let's just make this function here. We're gonna do that. We're gonna leave this here for a second. So this should be old value, new value. Yeah, this stuff is getting... I don't know if wrapping this in a function is better or if I should just like... I think wrapping it in a function is probably better. I think we should just do it like this, even if it's like a little bit slower. If I need to optimize it, I'll optimize it, but like, I think there are much larger bottlenecks than this. Okay, so we want like... what the fuck am I doing here? We shouldn't have to erase uses at that point, right? I think that should just be a no-op. I'm scared to test it though. Huh. Oh, do I need to... Oh. Okay, this is getting really annoying to do. We'll do that. I think that's all we need for that, though. Yeah, okay, this makes sense. I think the rest of this we can leave as is, though. Let's just make that for now, so this compiles. Real quick. It does not make. Inst combine. What broke here? Okay, we need to... We'll figure that out in a second. We'll comment that out for now. What else did I delete? Oh, I deleted that? Okay, so we just added that, which is fine. I'm gonna see what happens if we get rid of the erase uses pass. I think it should be a no-op, if I'm not mistaken. It passes up to here, so I'm lazy. We're gonna be quick with it, because I'm running out of time. Yeah, what happens if we just get rid of this? Just out of curiosity. Delete that, delete that. I think that should just be a no-op if we're replacing all uses of it, right? Like, and I is bin up here, so like that should just, this should just be a no-op, right? Let's try that. Yeah, that just works. So like, what was I doing? I guess we did need to like get rid of it, so it's like fine, but still. That should just be a no-op in pretty much every case here. Yeah, and if all of this runs, then like we will be fine. Okay, cool. So that does just pass. Okay, so now we have this nice little replace uses helper, which is also very nice. So now we can nuke all of this real quick. So we can do replace uses bin op folded literal. And that lets us clean this slop up a little bit more, which is so nice. Okay. So now that also means we can get rid of this stupid thing as well. We can clean this up a little bit more. What are we replacing uses of here real quick? Bin op with var. Yeah, okay. Okay. Let's add middle end utils. Replace uses helper. Okay. The day this compiler guy has no fans left, it'll mean I've left this world. I appreciate it. I appreciate the sentiment. Love the skill development. Appreciate. Yeah, appreciate it a lot. I still do like. There are some things that I do vibe code because I don't care about it, or I'm just like too lazy to write the actual code. But like for stuff like this, where like writing the code by hand is part of the fun, it feels a little bit ridiculous to do. So I try to avoid that in like these sorts of cases. Okay, let's do that. We can uncomment that now. We need to change this with constant. We also don't need that anymore. Oh, we need to yoink that there. This is still very boilerplate, but it's a little bit better now. We've cut out a bunch of lines. Yeah, we've gotten rid of 23 lines. So this is only 200 lines now. Yippee, yippee, yippee. God damn it. Let's see. Let's make a... Should we make a lambda in the lambda? How do we feel about that one? Is that like pushing it a little bit too far? How do we feel? I think that's going a little far, so I don't think we will do that. Okay, let's rebuild. Let's see if this does everything we want it to. This should fail tests. Yeah, it fails those tests. That's ideal. That means our transform probably worked. If it's failing just inst combine, I think that's good. This is gonna be very slow. Let's just regenerate tests while we wait. Yeah, and then that should be good. Yeah, that fails all the inst combine. It fails one Fibonacci test, interestingly enough. Not sure how that happened, but that's kind of funny. Yeah, we'll wait for this to run its course real quick. Okay. Why did it fail? Wait, what? Very dead ass. That test should not be failing. That's just one random ass test that fails. Whatever, sure. Let's just run all the tests again, because I'm curious. Is that a one-off, or like... If that's a one-off, then like, why is it failing? It looks like it ran fine. Let's see the final output. Yeah, so it ran fine. That's really funny. I think we should probably wait. Star.mir. Okay, yeah, that's a good thing to change. Yeah. There's another commit. Times 0 identity arithmetic simplification. Okay. I think with that is a pretty reasonable place to call today. We got pretty far. I think that's almost all, if not almost all, of our simplify slash reassociate pass. I might do one more look over it next time, but I think that's pretty sufficient for the time being. Thank you all so much for showing up today. Like the stream if you haven't, sub to the channel if you're new. While you're down there, check out the description. My Discord is there. It's a pretty chill community, and it's the best place to get pinged when I go live and stay connected with everyone else. My LinkedIn and GitHub are down there if you want to add me, and my GitHub sponsors is also there if you want to give me money. Yeah, I'm gonna go enjoy my evening now. Take care, y'all. Thanks for stopping by. Take it easy, and I will see you all tomorrow.